So we've talked a lot about composite functions and making a new function based on this composition operation. One thing we haven't really looked at though is the domain of a composite function, because we kind of have two aspects to this now because we are making a function out of two different functions. So there's kind of two steps we have to look at for the domain. Right? So if we remember the picture that we drew for f of g of x, okay, so x goes into g, which gives us the output g of x, and then g of x, this goes into f, which gives us the output f of g of x. So the domain values are the inputs, right? But in this sense, we kind of have two different points of entry, right? We have these x's, which are going into g, and then we have these g of x's, which are going into f. So we have to take both of these into account. So the domain of f of g of x is not as simple as just the domain of the resulting function. We also have to consider the g of x function that went in. So it's going to be the x values which are both in the domain of x and the ones that allow g of x to go into f with still being defined. So let's look at an example here. A lot of the ones that we did, the primary functions we were using was a linear function and a quadratic function in the previous videos, and both of those have domains which are just all real numbers. So we didn't really need to think about the domain at all anyway. So let's look at an example where we have two functions which have domain issues. Okay, so 5 over x minus 1 for f of x. And then we'll look at g of x equals 4 over 3x minus 2. So just looking at the domain of these separately first, just so we can think about it, this won't really have any bearing on the final answer, at least part of this won't. But the domain of f, of course, is going to be negative infinity to 1, union 1 to infinity, because the only value of x that cannot go into the f function would be 1, because it'll make the denominator 0. And then for g of x, it's going to be the same idea, except for the x value that causes a problem here will be 2/3, right? Just a reminder, you can find that by setting the denominator equal to 0. I like to say not equal to 0, just to make it more clear what we're doing. And then we just solve for this. We get x cannot be 2/3. So we get that the domain is negative infinity to 2/3, union 2/3 to infinity. In other words, we have all real numbers except for 2/3, right? It's the only number we're skipping over. So if we're looking at f of g of x, then part of this does come into play, right? Because first we have to, if we look at that picture again, right? First we're looking at the x values that can go into g. So that is going to be these ones right here, right? So in other words, 2/3 is going to be excluded from our final domain. Now we're not worried about the x values that are going into f. We're only worried about the g of x values that are going into f. Okay, so there's kind of two parts to this, right? So we did part 1, which is finding the x values that can go into g. Now we need to find the g values that can go into f. So we see right here that the values that are going into f can be anything except for 1. So in other words, we know that g of x cannot equal 1. And we want to find the x values that would make it equal to 1 so that we know which ones to exclude. Just like up here, we're finding the x values that would make this equal to 0. Okay, so we can set this up as an equation we can solve. Again, I like to say not equal to 1 instead of setting equal to 1, just because it's more clear about what we're doing. A lot of people will just set this equal to 1 and just solve it. It doesn't actually make any practical difference. It's just a notational difference. So we haven't really looked at how to solve equations like this. We'll spend more time on rational functions later. But on this one, all we need to do is multiply both sides by the denominator. Okay. So this allows the denominators to cancel out. So we have 4 does not equal 1 times, we could just drop that. We could just write 3x minus 2 here, right? And then this allows us to just solve it using the normal equation solving steps. We add 2 to both sides. We get 6 does not equal 3x. So x cannot equal 2. Okay. So we see that x cannot be 2 because that'll make g of x equal to 1. And then that's going to fail at this step where the g of x's are going into f. So we have 2 steps that we want to combine then. X can't be 2/3 because that can't go into g. And then x can't be 2 because that'll cause problems when the g of x's are going into f. So combining those, we get our domain as negative infinity to 2/3 union 2/3 to 2 union 2 to infinity. So in other words, all real numbers except for 2/3 and 2. Okay. Now let's flip it around and look at the domain of g of f of x. Okay. So now it's going to be the same thing, except for now we're looking at the x values that are going into f and the f of x values that are going into g. So for the first part, x going into f, we already found, right? We saw that x can be anything except for 1. So let's just write next to here, x cannot be 1 for this step. The f of x is going into g. Well, we saw in this part that x can't be 2/3 in that case. So now we're saying that f of x can't be 2/3. So we're looking for the f of x values, which would give us 2/3, because those are the ones that we'll want to exclude then. So we're going to say 5 over x minus 1 cannot be 2/3. Okay. So again, we'll multiply both sides by x minus 1. So this will give us 5 cannot be 2/3 x minus 2/3. Right, multiplying 2/3 by x minus 1 with the distributive property. We're going to add 2/3 to both sides here. 5 is equal to 15/3. So this is going to be 17/3. Cannot be 2/3 x. It's better to work with fractions if we can here to get the exact answers. You technically can work with decimals. We just want to try to avoid rounding, because in this step, everything's going to cancel out, right? So we're going to multiply both sides by 3/2, which is the same as dividing both sides by 2/3. So these 3's cancel. So we get that x cannot be 17 over 2. Right, so we multiply by the 2/3 to cancel, or the 3/2 to cancel out the 2/3. Okay. So x cannot be 17/2, and we already saw that x cannot be 1. So we will combine these. 17/2 is about 8.5. So it's going to be greater than 1. So our domain is going to be negative infinity to 1, union 1 to 17/2, union 17/2 to infinity.